All right, today we're going to extend what we've been working on with finding the trig function of any angle. Let's do a warm-up problem, just because once we're good with this, what we're going to do today is just an extension of that. Let's say that I was doing, I wanted to find the sine of 225 degrees. Okay, this is what we have been doing the last couple of days. Well, the very first thing that we need to do is find the reference angle. This is in quadrant 3. Okay, this is in the third quadrant, so I need to take the angle and subtract 180 degrees from it and get 45. That is my reference angle. So then, the next thing we need to do is draw my triangle in the right spot. So, since it's in quadrant 3, I want to draw my triangle in quadrant 3. And like we said, we always want one of the legs to be on the x-axis. All right? Now, my reference angle will go here, 45, which makes this a 45, 45, 90 right triangle. All right? And then we need to label it. Well, all 45, 45, 90s are 1, 1, radical 2, but since this is down, this is a negative 1. All right? And now we can just find the sine, and this is a negative 1, sorry. Both of those are negatives. So now I can just find the sine of 225 by working with this angle right here. Okay, we're actually going to do the sine of that angle. All right, so from this angle right here, the opposite side is negative 1. The hypotenuse is radical 2. And since we need to rationalize, let's go ahead and rationalize. I get negative radical 2 over 2. Now just a reminder, the hypotenuse, this hypotenuse right here is never negative because it's a distance. Okay, the hypotenuse will always be positive when you draw your triangle. Now, okay, there's a good warm-up. What now, we're just going to do some more examples here. What happens if, we'll call this example number 2. What if I wanted to find the secant of 330 degrees? Okay. Well, if I want to do the secant of 330 degrees, we do everything the same after we rewrite it. Remember, secant is the same thing as 1 over the cosine of 330 degrees. That is its reciprocal function. Now, once you do that, we are going to do all of our work next with just the cosine of 330 degrees. All right, because that's the one that we know how to use. Okay? Now, you can do that, or you can just use the fact that the secant of 330 degrees, it's the reciprocal of cosine, so instead of hypotenuse, or instead of adjacent over hypotenuse, isn't it equal to hypotenuse over adjacent? Right? Remember that? This way is probably going to be easier. All right? Otherwise, you're going to have to deal with multiplying. If you come over here, this is going to be harder, because you're going to have to multiply by a reciprocal, and it's going to have an extra step. So, let's just work with 330 degrees. It's in quadrant 4. So I need to find my reference angle, which is 360 minus 330. So my reference angle is 30 degrees. So we draw my triangle. Remember, it's critical that we draw it in the right quadrant. It's in quadrant 4, so I need to draw it in quadrant 4. And I need to label my reference angle. Here's my reference angle. So this is 30 degrees. That's the angle we're going to work with. We're not going to work with that 60-degree angle, but we're going to go ahead and label it so we know how to label our sides. My sides are going to be, the short leg is always 1, 2, radical 3, but this is a -1 since it's down below in the y-axis. And then I just remember that secant is hypotenuse over adjacent. So the secant of 330 degrees is we're going to work with this 30-degree angle. So we're actually working with the 30-degree angle. But the secant of 330 will be the hypotenuse over the adjacent side, radical 3. Okay? Hypotenuse over adjacent. Remember, secant is the flip of cosine. So everything is positive here, which is nice. I go ahead and I rationalize, and I get 2 radical 3 over 3. Okay? So if you're working with secant, it's just like all of the other triangle problems we've been doing. All right? You just have to remember that secant is flipped. Okay? It's hypotenuse over adjacent. Same thing for cosecant, same thing for cotangent. All right? Now, next example. What if I wanted to find the tangent of 7 pi fourths? The tangent of 7 pi fourths. Well, guess what? If I want to find the tangent of 7 pi fourths, we're going to do this the same way, but we need to get this thing into degrees so that I can work with it a little bit better. All right? So first, just in case you've forgotten, I can convert any angle in radians to degrees by multiplying it by 180 over pi. All right, that's our little conversion that we used because now my pi's will cancel. All right, 4 divided by 4 is 1. 180 divided by 4 is 45. So then 7 times 45 is 315 degrees. So you just make the conversion, and now we do everything else the same. Now I'm going to be doing the tangent of 315 degrees. All right, so I'll go ahead and finish this one. It's not going to hurt us to have some extra practice. 315 degrees is in the 4th quadrant, so I do 360 minus 315, which is 45 degrees. So I'm going to draw my 45, 45, 90 down here in the 4th quadrant. It's not a very good triangle, but that's okay. This right here is going to be my reference angle. Of course, this is also 45. I label it as 1, 1, but this is going to be a -1, and radical 2. And then I just work with this 45-degree angle. So the tangent of 315, I'll work with that little 45-degree angle. Tangent is opposite over adjacent, so it's -1 over 1, which is -1. All right? Now, the last thing that I want to hit today is what I call the reduction formulas. The reduction formulas deal with the situations where we have a negative angle. And they are very, very handy because we often don't like negative angles. So here's the reduction formulas. The sine of a negative angle, these are like a theorem or whatever you want to call this, an identity. The sine of negative x, or of a negative angle, is equal to the negative sine of the angle. Now, how would that work in the real world? Well, let's say that I had the sine of negative 300 degrees. Well, according to this little property, this is the same thing as the negative sine of 300 degrees. Okay? And that's all you got to do. So there's the first one. Cosine is really nice because the cosine of a negative angle is just the same thing as the cosine of the positive angle. It's kind of strange that way, but that's the way it is. The cosine of a negative angle is the same thing as the cosine of a positive angle. All right? And tangent is just like sine. The tangent of a negative angle is equal to the opposite of the tangent of the positive angle. All right? Now, how does this affect our work? Not much. It's really just placing the sine in the correct place. All right? So, if you look up here at number 1, if I am asked to find the sine of negative 300, I just use my rule and put the negative out in front, which isn't that like multiplying by negative 1? Okay? So this would be negative 1 times whatever the sine of 300 is. And we know how to find the sine of 300. All right? So we just find it and then we multiply it by negative 1. So let's do one of these. Let's say that we were asked to find the cosine of, no, I don't want to do cosine. I changed my mind. I want to do sine. Let's do the sine of negative 240 degrees. If you're asked to find the sine of negative 240, we know from our reduction formula that the sine of a negative angle is equal to the opposite of the sine of the angle. So the sine of negative 240 is the same thing as the opposite of the sine of 240. Okay? So in other words, all we have to do is find the sine of 240 and then multiply it by negative 1. Negative 1 times the sine of 240. That's all we have to do. So the sine of 240, let's start working with that. Reference angle, isn't this quadrant 3? Okay? So in quadrant 3, I do 240 minus 180, which is 60 degrees. So I draw my triangle in the third quadrant. It's a 60-degree down here. This is 60. That's the angle we're going to work with. And of course, it's a 30, 60, 90. Labeling this thing, it's going to be negative 1, 2, negative radical 3. I don't know what happened with my pen there. And so now I need to find the sine of 240 using this 60-degree angle. So sine is opposite over hypotenuse. So that's going to be opposite over hypotenuse. It's going to be negative radical 3 over 2. But don't forget, aren't we supposed to multiply this thing by negative 1? All right. So negative 1 times my negative radical 3 over 2 is going to make my final answer positive radical 3 over 2. and we will stop there for today.